sorry, something happened. It suddenly like got suddenly kicked me out from the software. I don't know why. But now we are trying to go back. So you understand what I was talking about, the different measures of variation. So one is range, low, largest minus smallest value. What's the problem with the range? If there is an outlier, it gives us the biased result. Then to counter that, if we have outlier, and the best interpretation of range is that we can say that the minimum range, if we go to the range tends to minimum, which tends to zero, the better it is because it is consistent. Consistent means less variations, right? Um, Less error. Less variation means less error between two different data points, and especially from mean. And then to encounter the quartile, we use interquartile range between two. So here we just skip away the below 25 and above 25%, and we just consider 50% of the distribution just to exclude the outlier. And that we just learned from the Excel, that how to calculate the variance in different form. So it's shown as a square, and how what does it interpret? We'll see. So we have done an example in Excel. Hope you have got it. Standard deviation. This is we are talking about the absolute measures of variations in the data set. Variation mostly from the mean. Yeah. See, it's from the mean. So standard deviation. So variance is just a deviation. We don't know it's like how precise this deviation is. But standard deviation, the problem with variance is that it gives us in the square, the unit of the variance is in square. For example, if I'm collecting the height of students, so the unit is meters, right? 196 meters, 100, my height is 196, but like different meters, right? So when we calculate variance, so the unit will be in square. So the answer will be meter squares. Do you understand? But so that's why we also use standard deviations. And here the unit is same. So what is standard deviation? We just show with SD. We also show with sigma, right? This variance is also shown by sigma square. Sorry, sigma is like this, right? Okay, something like this. Ah, why I can't draw the sigma? Okay, anyway, this is a sigma, right? And it's just a root of variance, right? So that's how we calculate. So here again, we calculate the same thing. And for example, in our Excel sheet, so 19.1 was the variance. So what will be the standard deviation? Will be under root 19.1, right? And let's see in Excel if we can figure it out. It's the same thing. So if I share the screen with you and see the example, so this is the example, this is the variance. So you can say under root. Oh, sorry, standard deviation, right? Let's take the root of 19. So what is the root of 16? 4. So it's 4 point something, right? Again, I forgot. Okay, I think I forgot the formula. So later I can tell you, right? But at the moment, let's stick to the camera. Yeah. So just take the root of 19.1 and you will get the standard deviation. Now remember, in variance, it gives the outcome in the unit scale, as I told you. And standard deviation gives in the same variable unit. Now question is that in what situation we should use range, we should use IQR, we should use variance, we should use standard deviation. So let's quickly describe that in what kind of situation we use these things. So I'm going to just erase this part so that we can have the names here and we can see the situations there. Mostly among variance and standard deviation, we usually prefer standard deviation. Two reasons, because same unit and it's more, it is less deviated than the variance. Um, let's say if we have a symmetrical distribution like this, right, with the mean in the middle of data. So if we have this kind of distribution, then we mostly go for mean, right? In this case, the best measure of central tendency is mean, and the best measure of variation is standard deviation. So when distribution is symmetrical, it's normal. Okay, you cannot see me, but anyway, it's not important to see me. So mean means x bar and sigma square. Oh, sorry, sigma is the standard deviation. So this is normally we use. If we have skewed positive or negative, right? Then what is the case? In this case, IQR is best. Interquartile range. Why? Because it removes the outlier and we just deal with the 50% of the midway. So in this case, what is the central tendency we use? Median is the best central tendency and IQR is the best measure for variation. Interquartile range. In case we have bimodal, then for average we take mode, and for range we take, for variation we take range. So these are the places, these are the situations where we use these absolute measures of variations. In case of bimodal, remember, for central tendency, I repeat again that we use mode. In financial problems, mostly we deal with this situation, this kind of distribution, or this kind of distribution. It's really, really rare that we can have this kind of distribution in financial data. Mostly it's like data is like this, either concentrated in one side, in one tail, left or right tail, or in the symmetrical position, or we can say normal distribution. We will see what is normal distribution in the later on lectures. So I'm going to erase this. So now we know absolute measures of variation. Remember, mean and standard deviation are such measurements which considers the entire data, right? So that's why we take, for symmetry, we take mean and measures, mean and standard deviations. But outlier means standard deviation, and mean doesn't work when there is an outlier. So for that we use IQR. Okay. Now let's see what is a relative measure of variation. That is coefficient of variance. This is very easy of variation. We denote it with CV. It also shows us that it's a standard deviation upon X times 100. As it is a relative term, so it gives us in proportions, means it gives us in percentages. So what is coefficient of variance? Is it a good measure? Yes, actually, it's a really good measure to the why? Because of consistency. For example, we want to check that if one stock performs consistent or another, then we take coefficient of variance. How? Let's say we have two stocks, stock A and stock B, and I want to see that which stock is more consistent, which stock have less variation in the prices, right? This is the prices of stock A and stock B. So because I need to know that where I should invest, okay? So that's really important. So how are we gonna do that? First, I'm gonna take coefficient of variance of A and collect the stock prices of stock A, right? Similarly, we take coefficient of variance of B because we have X of A already and X of B. So we can calculate standard deviation. You know that, right? How to do that? Okay, let me just quickly tell you. So this is XA is a stock price of A. So we take XA minus X bar A, take the sum, then XA minus X bar A square, and then take the summation XA minus X bar A square divided by N. So this is variance, and then under root of variance is standard deviation. So we can get this from this way, and then we can put XA and into 100, and then we can get this value. Similar process we're gonna repeat for stock B, right? And we can get these two values. So now if coefficient variance of A is less than coefficient variance of B, then we will say that this stock A is more consistent. So any if coefficient of variance is lower among different coefficient of variance, then that variable is more consistent, means that variable has less variation. Remember one thing, we can repeat it for different things. For example, we can see the stock A and first prices, and then we can also see the returns, that how much return it gives on different investment. So here we can get coefficient variance of stock A regarding prices, right? Regarding prices, regarding returns, right? Do you understand? And then we can see that which one is minimum. So let's say if CVBP and R, this one is the minimum than rest of it. So we can say that, how to interpret this? We can say that stock price of no, stock B is more consistent in terms of having return, right? So we should invest, if we are looking for returns, then we should invest in stock B, our money. Do you understand? Have a look. Have a look here for a few seconds so that you can understand. Yeah, now see, let's see the screen again with share screen. And we have this example. So how to calculate standard deviation? So we can say square root, oops, SQRT. So square root of which one? Of 19.1. That's 4.37. So that's the standard deviation, right? 4. And if we take like you can simply apply the formula, and that's standard. No, not this one. Standard deviation. No, this is the return of the sum of square of the standard deviation of the data from sample mean. Let's see. No, this is not the data. I don't know what the Excel formula, but that's how we get the square root. But this is the standard deviation of the square root of the variance is standard deviation. So now, in case of getting the coefficient of variance of this x, we will see it's we know it's a standard deviation. We have to, for each x, we have to calculate the coefficient of variance. Oops. So it will be x bar. X bar is 11. And this one is 39%. So there is a 39% variation in the data, right? So that's how we do the standard deviation stuff. So now you know the measurements of variations, right? So it's easy to calculate. Distribution, we will talk about the distribution in later sections, especially in next chapter. So at one moment, you can have more than one coefficient of variance to calculate different. Which one is better in what attribute? Do you understand? So remember, this is really good because of its less consistency. So it's the formula is standard deviation by x bar times 100. That's a percentage. Okay. So now we went through the measurement of variation. Now let's see the properties of arithmetic mean. AM, which is x bar. So first property, x bar means, what is x bar? Sum of x by n. So first property is that sum of x minus x bar is 0. How? You can see. What numerically we can say in this, numerically we can say, for example, this is x minus x bar. So what is the sum? Where is the screen? Like, look. So here, let's say another example. We have this is the score of 10 students, and we have y minus y bar, which is when we take the sum, it gives us 0, right? So that's numerically we can prove that. that, okay, you put scores in the data. So if the distribution is symmetrical, because we take standard deviation mostly in symmetrical way, and our arithmetic mean in a symmetrical distribution. So in a symmetrical distribution, the mean is thus from their mean, the deviation from their mean is always 0. All right. So this is mathematical. Can you draw analytically? Yes, we can. How? Let's see. This, how to make it true. So remember, we have learned the properties of summation, that if summation is attached to the constant, it gives us n something, some constant, right? So summation of c is, let's say, x plus c. So when I open the summation inside, then it will give us sum of x plus n c, right? And that constant. So here, if we open, so summation, so because x bar is a constant, right? So summation x minus n x bar. So we know x bar is this. So it means sum of x minus n, sum of x by n, so cancel, it will give us 0, right? So that means that in a normal distribution, the deviation from the mean is always, sum of all the deviation from the mean is 0. So that's number one property. Number two, these are the properties of arithmetic mean in a normal distribution, in a symmetrical distribution, okay? So number two, variance property, that is sum of x minus x bar square is minimum at x bar. How to do that? It means sum of x minus x bar square should be positive, right? Oh, sorry, it should be minimum, means close to 0. That's minimum. What is positive? So for that, we need to take the derivative. If you know the derivative, the dy by dx, if y is a function of x, dy by dx is d function of x upon d of x. That is change in y upon change in x. That is deviation, again, x minus x plus error minus x by error, right? So that's the formula, but we just simply know that if y equal to x square x, then dy by dx is 1. If y equal to x square, then dy by dx is 2x and 2 minus 1, which is 2x, right? So just remember this if you don't know the derivation. So here, take the first dy by dx, partial derivation of this. So partial of sum of x minus x bar square upon partial x. So what is this? 2 will come here, summation x minus x bar, and remember we have to derive with x bar. So, and it will give us minus 1. So it will give us minus 2 sum of x minus x bar, right? So first order condition is that this thing is 0. So we put first order condition, that is minus 2 summation x minus x bar equal to 0. So it means sum of x minus x bar equal to 0. So sum of x minus nx bar equal to 0. So if we see if it's true or not, right? And we know that it's true, right? Sum of x minus x bar equal to 0. So from here, this is first order condition, which is 0. Second order condition means we again take the derivative of this one, and it should be less than, it should be greater than 0. So if we take again sum of x minus x bar, we again differentiate with x bar. So it will give us what? It's 1, which is minus right? So it's already -2. So minus is already here, right? When we get this. So we're going to do this -2 and this. So minus is already there. So when we derive inside, so it will be 1. So it will be -1. So it will give us minus plus, right? So plus 2 sum of x plus 2n. So which is greater than 0. So this means it's minimum. So that's the second property that we proved, that you just need to write that x minus x bar is minimum, and you have to derive it second time. First time it should put it equal to 0 and then derive it again, and it should be, the answer should be the greater than 0. Understand? Just note down, then I will remove it. Then we have further properties of arithmetic mean. What is that? Y, if y is if a is constant, then y bar is also a constant, right? Then we know that if y equal a times x, the both are variable, then y, this applies, y bar should be ax bar. They all have proofs, but we are not going into that. Then if y equal ax plus b, this applies y bar equal to ax bar plus b. And similarly, it's minus. If it's minus, then it's minus. So they are different. Arithmetic means property. Now the one more thing, which is so we discussed almost all of it except this one. I can move it back to the camera. So you know how to do that, right? So we already discussed these properties. So these are different properties. So similarly, we have properties of variance, that if y equal to constant, then variance of y is 0. There is a proof, but we're not going to do that. You need to know that a square variance of x. So because we have the data here, y and x, so it's really easy to calculate, right? So variance of y equal to a square variance of x. And that's how we calculate the properties of variances. Next, dot plot. Dot plot means any plot which is there, simple, right? So let's say there are 8 units are produced and their pull off forces are measured in pounds. It's a weight force, right? So the dot gram is very useful to plot. So whatever x you have, right, and y you have, you just plot it, and wherever you get the value of x and y, you just put one dot. This is, so that's how you can see the distribution. So if distribution is like this, so I can draw that this is the line graph, and this is the dot diagram. So it's useful for displaying a small body of data. Like if you have less observation, 10 observation, then you want to show y, because you can easily find see the where the midpoint is located, and how much scattered the data is. Is it like condensed, or it is like really the spread is really high? So next class, we're going to talk about the box and whisker plot. Let me tell you briefly what we're going to do in the next class. Then we will see how to interpret standard deviation. So we're going to use different confidence interval concept. We're gonna cover it. We're gonna do some examples as well. We could have done it today, but there's not enough time, so we will do this in next class. So I will give you the whole PDF now, so that you can see. You can go over through. These are some basic formulas. We're gonna do that, and then at the end, we will see this in this way. Okay, so now hope you have understood